How can we predict the probability of an event before it even happens? That's exactly what random variables and probability distributions allow us to do. They are the foundations of probability, statistics, data science, and quant finance. So let's learn how they work. So we're going to first get right into what a random variable is. A random variable is a variable of which the value it is assigned to is completely down to a random process. Basically, we don't know its value until the experiment is done. However, we can know all the possibilities of numbers it could take on. So let's say a coin flip. Our random variable is x, which takes the value 1 if it's heads or 0 if it's tails. So right now, we don't know x as the flip hasn't happened, but we will know x after the flip has happened. This is where a probability distribution comes into it. A probability distribution will give every possible value a random variable can take. It will also assign a probability to these values. So if we were rolling a die, the random variable can be either 1, 2, 3, 4, 5 or 6. And then the probability of each random variable is 1/6. One thing to note is that all the probabilities add up to 1 because one of the outcomes must happen. There are different types of probability distributions, and the most common ones are a normal, uniform, and Bernoulli distribution. The simplest distribution is a uniform distribution. Every possible outcome has the same probability, like rolling a fair dice or flipping a fair coin. So remember, that is uniform as all probabilities are the same. A Bernoulli distribution is a distribution with only two outcomes. So either a success or a fail. You could say, once again, a coin flip, it is either heads or tails, or the colour of a random play card, red or black. And the probability does not have to be 50-50. For example, the probability a factory product is defective or not. So that is a Bernoulli distribution. Finally, a little bit more complex, but probably the most common distribution you'll run into. A normal distribution. This is where outcomes closer to the average have a higher probability and further away from average outcomes have a lower probability. This is represented with the bell-shaped curve. For instance, if I were to take random males' heights, there is a higher probability of getting a male that is, say, 106 centimetres tall compared to a male who is 2 metres tall, as the average height for a male is 178 centimetres and obviously 176 is much closer to 178 than 2 metres. And then that is all we need to know up to this point. These are the main distributions to run on. Of course, there are more, but these are good to start with. Also, with the basic understanding of random variables, but they're not too complex anyway. If you found this video helpful, please like the video and subscribe to support the channel, and I hope to see you in another video.